Okay, can you see that? Okay.
Yeah, we see your slide. Yeah,
Awesome, awesome. Well, thank you very much, Kevin, for the invitation. I've really been enjoying the conversations over the last couple of days. This has been really fun, really fun. Yeah, so before I dive into to my talk, I did want to find out about what psychology stats courses you teach. So Kevin, if you could launch that poll, that would be great. Or maybe I have the power, I don't know. Maybe I don't.
Sorry, was that the first poll
the
question?
First poll, please, yeah.
Yeah, I'll just give me a second here and I'll launch it.
Awesome. So I have a slide there that has the options. So which of the following options best describes your previous experience teaching statistics or quantitative research methods in psychology? So I've taught intro psych stats or quantitative research methods. I've taught advanced. So when you think of advanced, you can lump intermediate in there too, okay? You've taught intermediate or advanced undergraduate psychology stats or quantitative research methods, or you've taught more than one, so maybe a variety of levels as well. You've taught other psych courses that rely on quantitative research or none of the above.
Okay, so we have about 64%, 67%. They're trickling in, so if you can just...
Awesome.
Okay, so we're at 75%, so I think that's a good place to stop. And I'll just share the results and you can go over them if you like.
Awesome. So can everybody see the results? I don't know if participants can see.
Yep, someone just did chat.
Awesome. Okay, so 51% say that you're teaching multiple psych stats courses. Yeah, and then there's some none of the aboves. Yeah, I'm one of the none of the aboves. Yeah, so I have not taught psychology statistics before. I'm a statistician. So my background, I guess, well, I minored in psychology, my undergrad, but my undergrad was in math and stats. And then my grad studies were in statistics and biostatistics. But I've had a bunch of years of experience teaching intro stats for non-stats majors. I also teach courses for stats majors, but here I'm focusing on my experience for the non-majors. So these were not psych stats courses, although a couple of the courses psychology students could take. So they had to take a stats course out of a list of options. So I've taught at a few different places in southwestern Ontario. So I spent some time at University of Western Ontario, and I saw Jennifer Peter up there last. So she and I collaborated on the biology statistics course. And most recently, I'm going to talk about my experiences at the University of Toronto, and I work with Jasti Singh on our introductory statistics course there. While I was at Western, I also developed and taught a course on teaching statistics for graduate students, and these students, it wasn't just statistics students, they were from all over the place. So I did have some psychology students who took that course as well. And then I've also recently done a Scholarship of Teaching and Learning project looking at Stat 288, so that course that I teach at U of T with Jasti Singh, and just finding out like how our students are doing. Are they prepared to actually engage with stats in life sciences research afterwards? So this talk will focus on the blue highlighted things, so Stat 288, its development and what we do there, and also the Scholarship of Teaching and Learning piece, but my opinions about things and my practice, it's really been informed by all of these experiences. So plans for the talk then is just to talk a little bit about the motivation and the background of this course, talk about the course development, describe the key features of this course, and highlight relevant project findings from that Scholarship of Teaching and Learning project, and then think about what we can take away, like I guess for my practice in teaching stats for life sciences, but also like what can we learn that perhaps might be applicable to teaching stats in psychology. I'm hoping that there'll be something valuable that you can take away from the talk. So now I'm thinking life sciences. So thinking about the motivation behind this course, well, we know this has come up in the psychology context. There's a lot of misuse of statistics in the research literature. Lots of errors out there, even in high impact journals, and high reputation journals. When we look at the statistics education research, so Joan Garfield and Danny Bensby, they're big names in stats education. They're from educational psychology and education backgrounds. It's well known that inappropriate reasoning about statistical ideas is widespread and persistent, similar at all levels, and even among some experienced researchers. And another problem here is that it's quite resistant to change. So when people have conceptions about things, misconceptions about statistics, it's hard to change their minds. So there's been lots of calls for improved or more training statistics for life sciences. So in winter of 2016, so just as I was coming to U of T, the human biology and pharmacology and toxicology programs approached my department, so the Department of Statistical Sciences. And I should also say, I've always lived in stats departments. So I've never been outside, even in my grad school. So they approached our department to explore the possibility of developing and offering a joint course tailored to their students. So if you have a new course, a new stats course to teach, I guess I'm curious, how do you decide what to teach and how to teach it? So I'm asking you to select all that apply. Hopefully that's an option in the polls, I don't know. And I don't know if I've captured all of the possibilities here, but yeah,
Okay.
together if not.
I'll launch that now, is that okay?
Sure, thank you. Yeah, so pick all that apply. So use a good textbook as a guide, collaborate with psychology colleagues, collaborate with stats colleagues, align plans with course or program level learning outcomes, participate in relevant conferences, like this one, review stats ed literature or other scholarly work or other.
Okay, so we're about 59% voted.
Okay.
61. Looks like we've hit a bit of a stall.
All right, well, let's see what people are saying.
Well, as soon as I said that, 4 more percent jumped
Yeah.
up. 1 sec.
Okay, so that's good. Program level learning outcomes. So that was a discussion that came up yesterday. Good, awesome. And other, I'm curious about the others, but I can't see the chat. I know, like, maybe it was yesterday, teaching what we've taught and how we've been taught it is probably something that we do. We go back to what we know, but there might be some other interesting others out there. Feel free to share. Share in chat if you want, but I can't see it.
People can also put that in the Q&A panel if they want, and we can bring them up. Yeah.
Yeah, so feel free to share. I'm going to keep chatting though. Yeah, and Kevin, you can just chime in if there's anything that comes up.
Okay, thank you.
Okay, so what did I do? Well, I mean, I'm a statistician. And yes, I had lots of experience. I kind of have a good sense of like what we should do in intro stats, but we needed to make sure that this is what the students needed and this is what their programs needed. So I wasn't the person to make those decisions. So I did a needs assessment with the programs who wanted this course. So a bunch of faculty in those different units responded to that. I asked them, what should your students know and be able to do at the end of the course? What statistical methods should they be familiar with at the end of the course? And what inference procedures should they be able to do? So then after that needs assessment, and I'll tell you where we landed in terms of learning outcomes based on that shortly, but after that needs assessment was done, we put the course proposal in and it went through the approval process and it was in the calendar so we could offer it for the first time in the 2017-18 academic year. So this is where we landed in terms of learning outcomes. And if you read through this, there's no topics here really at all, or no methods, no specific methods, but very ambitious for a half course in statistics, perhaps the only course that they ever have to take in statistics for their programs. There's a lot going on here. It's only 12 weeks. So the programs wanted their students to be able to not only be critical consumers of statistics and research papers, but also to be able to collect their own, well, design their own studies, collect their own data, analyze it. So they wanted them to have software experience as well. Yeah, so this is doable. Like we've done this. Jassie and I have worked on this, and we think we're doing a good job. Our students seem happy, but I guess a really important learning outcome here is that last one, because there's no way that we can possibly teach everything that the students are going to encounter in this one course. So they have to recognize when standard statistical practice procedures are not appropriate and know to seek statistical expertise early in the research process. So course development, we always take a scholarly approach to course design, so guided by best practices in higher education more generally, but also, and I post a link to this, the GAZE guidelines, so the American Statistical Association endorsed these set of guidelines, the guidelines for the assessment and instruction in statistics education. I posted a link along with a link to my slides there in chat earlier, if you'd like to have a look. These came up in a couple of presentations already. Yeah, so it's important that we teach in this first statistics course, we teach statistical thinking. So teach statistics not as just a collection of tools and inference procedures, but as an investigative process of problem solving and decision making. Give students experience with data and multivariable thinking. Focus on concepts. Integrate real data with context and a purpose. Foster active learning. Use technology to explore concepts and analyze data, and use assessments to improve and evaluate student learning. So those are things that I hold near and dear and try to incorporate in all my statistics courses. Okay, so this is not a traditional statistics course. So this is taught, it's developed and taught collaboratively with the Human Biology program, and Jasty Singh is an immunologist, and we have partnered to do this course. It's a true partnership. We collaborate on everything. So course activities, the assessments, everything. So all the lectures, tutorials, and labs and things like that, we work together on. And I think that's really helped make the course more relevant to students, and it helps, I guess, it helps meet the needs of the course and the programs. So this course is integrated with the scientific inquiry process. So it's in the name of the course, Statistics and Scientific Inquiry in the Life Sciences. And it's very non-traditional in that very conceptual, more simulation. So it's not a simulation-based inference course like it came up yesterday. So it's not that far, but use simulation a lot to explore the behavior of different things. So statistics and p-values and confidence intervals and that kind of thing, and to explore power. We don't use calculations. We don't have a lot of formulas at all. And the students are happy about that, but we're using R, and we're focusing more efforts there than the formulas. And we're focusing more on conceptuals. It's more important that the students understand what these things mean than necessarily where they came from. We also have less of an emphasis on probability. So we do everything through simulation more than using probability rules. So lectures and tutorials, that's kind of the foundation of the course. And we don't really, like, you could get away without having a textbook in the course, but we do have one because students like to lean on a textbook, and it's nice to have, it's nice for them to have a resource where things are explained in a different way. So we started out using the basic practice of, or no, the practice of statistics in the life sciences by Bridget Baldy and David Moore. That's a W.H. Freeman book. They have great supplementary resources online as well. This year, since we moved online, we just wanted to simplify, so we went with an open option. So it's an open intro stats textbook, introductory stats for the life and biomedical sciences. So what we did is, there's not really a textbook that really fits what we do because we really de-emphasize calculations and formulas. So we had to map what we did, or map what was happening in the textbook to what we were doing. So we just limited it to relevant sections and avoided any hand calculations. But we did give them some practice problems to work with as well from the books. We used our studio. So we either coach students to install it on their own machines, or we used a cloud-based solution. So there's our Studio Cloud, which used to be free, but now they're charging for it. But U of T has a cloud-based option as well that's available. So students just need an internet connection to be able to access that environment. And that helps because you just don't have to walk everyone through troubleshooting installation on their own machines. That's a huge help. So those are our computing labs, and then our project. And I'll say more about those shortly. So the whole course was built around the statistical investigation process, which is like the scientific method really. Start out by determining what the problem is, coming up with a plan to address that problem, collecting some data, analyzing it, and then drawing a conclusion. So statistical ideas have to be addressed at every stage of this process. So all too often, people go out and collect some data, so they design their study, they get their data, and it comes to analysis time, and then like it's hard to know like what method would be appropriate, and maybe the method that could be used for the data, it's not going to give them the answer that they were looking for in the first place. So it's really important that you kind of think through this whole process all at once, and make sure there's alignment between the different stages. So students had to complete pre-lab instructional videos that introduce our code to implement the methods discussed in class. And this was actually a collaborative project with Jennifer Peter, who is here. So Jen, if you want to put that link in chat, that would be fantastic, if you're still here. But it's also in my slides that I've shared already too. Then students had to work through lab assignment questions based on a real research paper. So Jasti has been amazing at finding really good research papers that have published their data. So the students are working with real data that were used for that paper. We use our studio, and students do these assignments in our Markdown. And I see that Wesley Burr is going to be speaking next, and I think he's going to talk a little bit more about doing this. And the students have to produce appropriate summaries and inference procedures and interpret their results. Another important feature in all our lab assignments is we ask students to attempt to reproduce some of the figures in the paper and to evaluate the appropriateness of the method. So this is an interesting exercise because more often than not, even though we don't go out of our way to find papers that have issues, students struggle with this because they don't have enough information. There's not enough information given to figure out what the authors actually did, or the methods they're using don't really match the way the data were collected. So this is just a really good exercise for the students to go through. The group research project, this is where students really get to experience the whole PP DAC. That should be PP DAC and not PDD DAC. Yeah, so the whole scientific inquiry process from the beginning to the end. So they have to frame their own question. They have to do a literature review to inform that question. They have to, you know, figure out how they're going to sample from the population, come up with a study design, and then collect the data and analyze it. So they had to do a proposal where they had a literature review and came up with a plan for sampling and study design. That proposal was peer reviewed by others in the class as well, and then graded by the teaching team. So they got feedback on that. And then they proceeded to collect their data and analyze their data, and they prepared a report in R Markdown. So they got to see the whole process. They got to grapple with statistical issues at every stage. So this, what we used here is we used a virtual simulated population, which is really cool, actually. So it was developed by Michael Bulmer. He's at the University of Queensland in Australia. Yeah, so it's a virtual population. You can go in, you can sample individuals, you can take measurements on them. You have to get their consent for participation. So it really mimics how research on humans might work. And there's lots of different things that you can measure on these populations. And this is free to use. We've used this ever since we started this course, and it's a huge hit every year. Yeah, and I should say that the research project and the labs together, so this is where the students are actually working with real data in R, that's worth 53% of our course. That's how much it was worth this year. So it's like heavy emphasis on working with real data and interpreting real data. So next question is well, how is our course going? So is it working? Remember, our goal is to prepare life sciences students to engage with quantitative research or engage with statistics and quantitative research. So we did a scholarship teaching and learning project on this a couple of years ago now, and we partnered with previous students. So we hired them on as RAs. So they took Stat 288 the first time around. And we did a survey study. So we did a pre and post survey, and we looked at a bunch of different things. So like we looked into self-efficacy, we looked into are they able to answer specific questions about stats, and also we were trying to ask them questions about like how would they handle different situations in practice. So I'm not going to go through all our results here. I'll just pick out a few to highlight because I do want to have a discussion a little later on about reflecting on things. So in terms of self-efficacy, so we have the pre-scores on the horizontal axis, the post survey on the vertical. As you can see here, the majority of students, their confidence level in choosing the correct statistical procedure and interpreting the results of the statistical procedure, they seem to go up. Okay, I should say too that our sample size here was 126 students, so that was 83% of the class participated. So they're more confident in their ability to correctly choose statistical procedures and to interpret the results. But does that mean that they can do it? So this question kind of was trying to mimic a situation they might come across in while reading research publications. So actually we grabbed this figure from a published paper, and we built an experiment into this study, which I'm not going to talk about too much here, but we wanted to know if the source of this figure would change how they responded to this question. But I'll just say that we didn't see anything interesting there at all, like there was no effect. So I just kind of put them all together for the purposes of this conversation. So a neuroscientist student volunteering in a lab classified rod terminals in the retina as either bipolar or not bipolar. So using a total of 6 mice, 3 for each genotype, either wild type or Picatrend knockout, the student examined whether the proportion of the 2 rod terminals differ between wild type and Picatrend knockout mice. So what can we conclude from the student's chi-squared test here? So this was the figure. Then option A would be kind of us siding with, let's see, mice tend to have, siding with our alternative hypothesis, kind of saying that HA is true. And then option B would be not rejecting the null hypothesis. And option C would be rejecting the null hypothesis. And then D would be, we can't conclude anything from this because the measurements are not independent. And then E, yeah, and I don't know. So when we look at this, so they had 3 mice in each of the 2 groups, okay? But what are their N's? They're saying they reported N's of 260 and 361. So the N's were actually 3 and 3, but they're analyzing the data like all of those measurements were independent. So we have clustering within the treatment groups here. So it's not appropriate to use chi-squared. So really the correct answer here should be D. Should be D, or E would be good. They recognize that they don't know what to do with this. But let's see what they said. So I didn't link these. I kind of looked at the pre and the post separately. I could have linked them, but this is quite telling too when we think about what this means. So on the pre-survey, we asked them this question, and the majority of the students kind of went with the descriptive approach. So they're not really thinking about inference here. They're thinking about, well, what did my figure look like? What did my data say? So it looks like HA is true based on my data, okay? But when we went post, students went with that p-value and they said, well, this means that we reject our null hypothesis here. Jessie and I were both very sad to see that very few students at the end of the course went with the not independent answer. So, I mean, it was nice to see that they've changed their thinking from just thinking in terms of the observable data, thinking in terms of the sample, to thinking about inference procedures, so using that p-value, but they used the p-value without questioning its origins. So the p-value was very misleading. It wasn't appropriate here because the model was wrong. Okay, so that was one thing. And another question we wanted to ask them, we wanted to kind of push their knowledge boundaries. So we wanted to get them to grapple with a situation that they don't have a method for based on the methods that we covered in class. So this example, the students worked together to actually come up with this example as a realistic example they might see in a 3rd or 4th year lab course. So suppose we're in a lab course where we're working with a group of students to collect data on the effects of different drugs on blood vessel constriction. The experimental apparatus is set up so that an artery is mounted on a contraction measuring device in a bath. Different drug solutions can be added to the bath. The baseline contraction is measured, then the contraction is measured after adding drug A, then again after drug B. And then it talks about like how it's emptied out and washed out before drug B is added. Okay, so we have a repeated measure situation here. The students did not learn methods for repeated measures in our course. Remember, we only had them for 12 weeks and we had so much other stuff to do. So we didn't go there. In terms of so this was on the post survey. So we did have a random effects model and a repeated measures ANOVA there, but these are not methods that we talked about in the course at all. So they were listed as options. But we did talk about a paired t-test in the course. We spent lots of time on that. We talked about the independent samples t-test, the one-way ANOVA, the chi-squared test. We didn't talk about regression too much at all either. So there were methods here that they didn't know from the course. Only 43% of the students chose a method that could handle dependent samples. So that was discouraging. We have a lot of people choosing the independent samples t-test and the one-way ANOVA. Yeah, when there's definite pairing or dependence between those samples. So based on these last 2 questions that we asked at post, our students are not recognizing the dependencies in the data. So not recognizing the clustering within groups and not recognizing dependence across samples. Not as much as we'd like. Okay, so another important course learning outcome was that students see the relevance of statistical issues across all stages of the life sciences research process. So we asked them this question to kind of get at that. Suppose you're a researcher interested in looking at the effects of a drug on leukemia. For which of the following stages of research is an understanding of statistics important? So check all that apply. So reviewing the literature, formulating your research question, planning your study, selecting and enrolling your participants, taking and recording your measurements, summarizing, analyzing the data, interpreting your findings, and then we put an other there in case they wanted to add anything else. Yeah, and I bet you can guess at which one they thought statistics was, I guess, most important for. I can't see the chat, so I can't see what you're saying, but let's see what the students said. So I have the results as a post. The height of these bars, the total height of the bars, are the number of students who picked that option on the post survey. The orange is, it includes, I guess, people or the numbers of people who answered or chose that one on the post that didn't on the pre. Okay, so we did see some gains on the research question and the sampling, and then a little bit on literature review, study design and measurement, a little bit. Nothing really happened with interpretation, so we didn't gain any votes on interpretation over the course. So yeah, this was something that we emphasized all through the course, so we were a little disappointed to see this. Of course, it's no surprise that they thought statistics was relevant at the analysis stage, but in the literature review, I mean, in order to be a critical consumer of the literature that's out there, you need to have statistics knowledge and skills. So that was discouraging. And then in terms of study design, experimental design, you need to think about your statistics there as well. And then the interpretation as well. It's like, what meaning can you extract from the analysis and the inference procedures that you use? Anyway. I think we're on to something. Jackie and I both think we're on to something, and good things are happening in our course, but we still have a ways to go. Another question we were interested in is just what would they do if they encountered a situation where they were asked to use a t-test, say, but they knew it wasn't appropriate. Okay, so suppose you're invited to join a research lab shortly after taking this course. Your research supervisor is hoping you can help analyze some data. You ask your supervisor for advice in which procedure to use, and they recommend a t-test since it's used all the time in that area of research. However, you doubt the t-test is appropriate. You don't think it's appropriate. So what would you do? So we asked them to rate the likelihood on or how likely they'd be to take each of these actions. So share your concerns with your supervisor, ask your supervisor if someone else could do the analysis, discuss the methods with others in the lab, review the methods sections of other related papers, look online for information about appropriate tests, refer to your stats course notes, conduct the t-test as recommended, contact a statistical consultant for advice, consult with one of your life sciences professors, reach out to a friend who took stats with you, contact the professor you took stats with. So maybe you have a guess at which one was they ranked as most likely, they'd be most likely to do. Take a guess, but I can't see chat. So just take a guess on your own. You're free to have a side chat on Q&A and chat if you'd like. Here's what we have at post. Yeah, so a lot of people are going to look online for information about appropriate tests. So something that Jasty and I do a lot in class is we warned them, and they actually experience this too. There's a lot of misinformation about statistics online. So they have to be super critical consumers of the information they find online about statistical tests. Remember, there's a lot of misconceptions out there, right? Like think about the stat ed literature. A lot of misconceptions out there that are very resistant to change. So there's a lot of information out there that's going to have misconceptions built in. So that was kind of disappointing to us. I mean, it was good that they were going to share their concerns with the supervisor, but depending on who the supervisor is, they might encourage them to use a t-test anyway. So they're going to look back at their statistics notes, discuss stats methods with others in the lab, look at methods sections of other related papers. So, I mean, again, that's risky because we know that the prevalence of statistical errors it's quite high. So if they're looking at other papers for advice, or it just might be reinforcing the errors and so on. So when we look down here, contact a statistical consultant for advice. Some would, but there were some that would be very unlikely to do that as well. And some people are going to conduct the t-test anyway, which hurt Shasti and I when we saw that. Fortunately, we asked this question in class in a poll this term just to see, and no one said they would do that. So I guess it's changing, but maybe that was just who was in the class that day, and they were worried that we could see what they were answering. I don't know. All right, some more work for us to do, and it's interesting to kind of think about statistical practice and what we can do, I guess, to try to support good statistical practice in our students. So my insights from teaching, my teaching experience and research, so collaborative multidisciplinary teaching, so I think that has been a game changer. So working with Jasti Singh on Stat 288 and working with Jennifer Waugh at Western on biology Stat 2244, it just makes for such a rich, more authentic quantitative learning experience for the students. And it's really nice to have both perspectives in there. I think it's good for the whole teaching team. So the prevalence of statistical errors, yeah, so when we knew it was a thing, but I know that every paper Jasti and I look at, we're interested in the paper. We're not trying to find errors, but when we actually try to dissect what was done, we find them. Some of them, are more consequential than others, but they're there. From the Stat 288 study, what we found is there was improvements to self-efficacy and the ability to choose correct statistical procedures and to interpret results. But many of the students are still not able to recognize when the basic statistical procedures aren't appropriate, and they don't see the relevance of stats in all aspects of the scientific inquiry process yet. And my big concern here is that they just don't see dependency in the data. And when you have dependency in your data, basic statistical procedures don't work. Yeah, so another takeaway is that one stats course is not nearly enough. So I'm so jealous of you guys in psychology because you have more than one stats course. That is good. Like a lot of students in other programs, they may have a required stats course, but some of them don't even have a required stats course. But then the students have to go on and be critical consumers of quantitative research. So I guess a really important, if they only have one stats course, a really important learning outcome then is recognizing the limits of their knowledge, and then just knowing what to do when they bump up against that. So that was kind of my life in statistics for life sciences. But let's think about how that might transfer over to statistics and psychology. I think it's pretty close, but it's not an area that I've really focused on too much so far. So there's statistical errors in psychology research. So this has come up a few times in the talks, and definitely lots of concern around reproducibility, and lots of mistrust of hypothesis testing. And then there's more reporting standards for quantitative research. So some journals are introducing these. They have introduced them. They're revising them. And there's definitely a need for improved quantitative literacy in psychology. So I guess my question, and this, Jessica brought it up yesterday, how does statistical training fit within the psychology curriculum? And do your students need to be consumers of psychology research or producers, or both? So this comes down to program level learning outcomes. And Jessica said that They're working, so STP is working on the, or I guess there's a task force who's working on the version 2.0 of these guidelines. So those would be good to use to inform your program level learning outcomes. And then just think about how stats fits in there. And then another important consideration is, how do you develop your students' statistical skills throughout your curriculum? So you can't think of a stats course in isolation. You have to think about how it connects to everything else, and how these skills are being reinforced throughout the courses, even if they're not, you know, quantitative research methods or stats courses. Okay. So this brings us to ideas of statistical literacy, reasoning, and thinking. And I did want to just point out that statistics itself is a separate scientific discipline. So there's a lot of collaboration. A lot of other disciplines use statistical methods, but we are our own discipline, and we have our own research agenda and so on. Like our students, we have lots of students at U of T. We have over 4,000 students who take statistics programs of study. And our students who prepare to be like professional statisticians or on their way there, they need to take 13 to 15 stats courses and like 5 to 7 math courses and a handful of computer science courses as well. So it takes a long time to get there. And like there's theoretical underpinnings and everything in statistics as well. And understanding those really helps us understand the behaviors of these different statistics and methods and so on, and the consequences of, well, when assumptions don't hold and so on. It would be awesome if all psychology students could do like a major in statistics as well, or a minor, but that's not going to happen. So I guess we got to think about, well, how can we build statistical thinking skills in psychology students as we go? So in terms of statistics education research, so Chris Wilde and Maxine Fancook have this paper, Statistical Thinking and Empirical Inquiry, and they've really tried to delve deeper into the complex thought processes of statistical problem solving. So this is a really interesting paper if you want to get at the messiness and the complexity of statistical thinking. They've also come up with some frameworks to talk about that. There's also this other area of research in basic literacy and statistics. Oops. There, literacy, reasoning, and thinking. So statistical literacy is just understanding and using the basic language of statistics and interpreting data representations. Reasoning is the way people reason about statistical ideas and make sense of statistical information. Statistical thinking, though, requires a higher order of thinking than statistical reasoning does, and it's more the way that professional statisticians think. So there are, and there's links here, and you have my slides. So there's an international collaboration for research on statistical reasoning, thinking, and literacy, and they have research forums every 2 years since 1999. So there's a lot of information and a lot of publications there if you're interested in that. This gray box that popped up, this is just something I found when I was doing some digging around to prepare for this talk. So this is something that might be nice to put in your courses. So it's some examples that have been put together on different applications that show statistical thinking and action. So Beth Chance and Alan Rossman are statisticians. They're very active in the stats ed community as well. So I can post that link for you if you like, or you can just grab it from my slides to have a look at. This is something else that I found fascinating, so I highly recommend this paper. So Rochelle Trachtenberg, she is in a neurology department. So she has a psychology background and some biostatistics in there. She developed this mastery rubric that looked at different levels of proficiency in statistical literacy for life sciences research, like neurology. Now, a caveat here is that she developed this thinking about doctoral level statistics. And I guess her goal here is to build a collective quantitative proficiency among like doctoral students. So it is kind of aimed at that level, but I think that we could take what she's done. So this is an awesome framework. Take what she's done and try to adapt it for our context. So like statistics for life sciences or psychology. So I'll point you to figure 1 there. She has 6 levels of proficiency. These are different ways students interact with statistics that have been presented in figures, or not figures, papers or grant proposals and so on, right from pre-literate to an expert or a master. And there's 6 levels, so it's interesting to see that transition. So I guess it would be a useful exercise to think about, where do your students have to be? So at an undergrad level, where do you want them to be at the end of their program? Where do you want them to be throughout their program based on the scale? Okay. And in terms of the things that I've found over the years really transformed, they've really transformed my teaching practice, is collaboration and scholarship. So collaboration with my life sciences partners, so Jennifer Waugh and Jasti Singh, but collaboration with my colleagues, collaboration with the broader stats community, with the broader stats ed community, with the science education community, with our teaching and learning center. So I've just learned so much from others. And also scholarship. So there is research on teaching statistics. There's a well-established statistics education research I guess, field and community. And so I've learned a lot from that, and just scholarship more generally in higher education, and my own scholarship that I do. So I do scholarship of teaching and learning, and go to lots of conferences. So like this, there's a lot of scholarship being shared, and wisdom and experiences being shared with the group. I did want to share another upcoming conference that, so this is at the end of June. It's the U.S. Conference on Teaching Statistics. It's virtual at the end of June. The abstract deadlines have already passed, but there is one option in there. They have a birds of a feather discussion where you can propose something, and then a bunch of people with similar interests will get together. I'm not quite sure what that's going to look like, but if you're interested in that, the deadline for birds of a feather proposals it's the end of May. I'll post that link to chat too if somebody already hasn't. And then there's also the statistics organization. So there's the ASA, and that's like, they endorse the GAZE guidelines, and they have a statistics and data science education section. And then we have our Statistical Society of Canada. We have a stats ed section, and Wesley Burr, who's coming up next to talk about R and reproducibility and things. He is going to be the president-elect of that section as of July 1, I believe. Yep. So the SSC, the stats ed section, we do have programming attached to our annual meetings, so stat ed programming attached to the annual meetings, but we also have other things that happen. So, and I'll post a link to this. Last June, we, or the stats ed section, hosted a webinar for teaching statistics online. So there's recordings there, and all our materials are there too. So I can post that for you if you'd like. So yeah, so I guess I'd encourage you to collaborate by doing things like this. And thank you so much to Kevin and Fergal and Rob for organizing this. I think this is fantastic, and it's a great way to get people with similar interests together. Yeah, so thank you. That's all I have to share. I have like a huge reference slide, but I won't leave it there. Yeah, you can look at the reference if you're interested in my slides.